Okay, in this chapter, we do this. And the same story. How about 1/4, a quarter of this area? It will be, what is the area of that? Same things, right? It will be 1/4 of, we multiply this guy here, pi r squared divided by this guy, give us this, right? Or it is, in other words, we can just remember this rule. This guy multiply this guy divided by this, which is 1/2 s times pi r squared divided by 1s. The s here will cancel each other. That is why we have this formula, right? And it is equivalent to saying that the whole pi here, the angle, the inner angle here, the center angles of this, it will finish 2 pi, right? From here, it cover the whole areas. 1/2 of this pi, it means that the angle will run from 0 to theta is equal to pi, right? It is pi, right? And here, if 1/4, it will be, what is it? Yes. If we do this, we're also able to find this area of the corresponding areas. Or in now. Now we can, yeah, I think it's better to start with this. We know that if the center angles here is 2 pi, we have that the area is pi r squared. Then for a given angle, let us call it theta or alpha to avoid confusion. If we have the inner angles here is alpha, what is the area of the corresponding area here? Let us call it A. The proportional rules tell us that the area of this will be this guy, right? Which is alpha times pi r squared divided by 2 pi. And pi appear in the numerator and the denominator. Therefore, we have the formula of this will be, yes, right? Okay, if you don't remember this formula, you can do it yourself, make some arguments to find this area. So that is the formula you see here in the first slice, okay? Where the angle here, we call it theta. Okay, are we good? Then, now, you can imagine this way. In order to find the area R in this figure of the curves, R is f theta, which is this curve. Okay? Imagine it's like a windshield blade. It's here, right? The length of the radius is this guy. If you rotate this line, the angle theta, it will cover the whole area here. Okay? So it makes sense to say that the delta A, which is the change in the areas, this guy and this guy here will follow the areas formula above, which is 1/2 of the radius square times, what is it? The angle theta, right? In this case, the angle theta is delta theta, which is small change in the angle theta. Just apply this formula, right? And R, in this case, is f of theta. Therefore, we have this relation, delta AI, which is this small part here, will be 1/2 of f squared delta theta. And if we approximate the limit here by finer parts, from I to N, right, it will give us the area of the whole things here. Therefore, the Riemann sum of this area is the limit from N is equal to 1 to, N goes to infinity of this sum, or we can write it as integral terms. Integral from A to B, where A, B are the limits of the angle theta, and 1/2 of f squared here, d theta. So again, one more time, it is very important to write this indicator, d theta. This implies that we are taking the integration with respect to the theta variable. Many of you, some of you did not write this d theta or dt, depending on the problems. And if you do not write that, it is completely wrong mathematically. So it's very important here. And some other mistake is this. You write the dot, for example, 3 times negative sine x. If you write this way, 3 times negative sine x, if you don't use the parentheses here, it's very confusing. So be careful. Do not write this way. If this is a product of a positive number with a negative number here, you should make sure that there's a parenthesis here, or you write it -3 sine x. Okay, and one more thing. When you answer a question, write it clearly what is your argument. Otherwise, if you write only the result, the reader may not understand and it's not complete. So write it carefully. Okay, go back to our problems here. So from now on, we can use this formula to compute the area of the curves in polar coordinate when the angle theta is from A to B. Okay. Or it is easier to memorize if we use this form. A is equal to integral from A to B of 1/2 r squared d theta. That's it. Okay. Now let us do this example together. And I decided to leave the whole solution this way so that you understand the way how we express our thought and how to argue in your test. So we need to write it clearly. We will want to find the area enclosed by the loops of 4 loops rows of R is equal to cosine of 2 theta, right? In order to do this one, the best way is to graph the curves here in polar coordinate system. So by doing so, you have to make a table, the theta and R, right? When theta is from, let us say, from 0 to 2 pi, and you pick some more points here in between. We've done these problems before, and we know that this graph is like this. If you practice at home, remember that we have this website. Okay, here, let me share this screen. Here. Okay, this website. This allows us to graph a function in polar coordinate. So for example, we are doing the function here, r is equal to cosine of 2 theta. Put it in here. Is it cosine of, sorry, cosine of 2 theta. In this case, they use notation t. Enter, right? On the left is the Cartesian coordinate. When theta play a role of x and r play a role of y, then this is the graph in Cartesian coordinate. And here on the right, you can change the value of theta to see how it behaves here. When theta is equal to 0, in polar coordinate, it represents this point. When theta increase from 0 to pi over 2, it creates this red lines here. And we continue when to 0 to pi over 2, it will be like this guy, right? Then we continue drawing it, it becomes this four leaves curve here. Okay, it's a very useful tool to understand it. So if you don't draw the graph here, it's very hard to find the area because some curves are crazy. So we need to look at this. So now, if we want to find the area of one loops here, right? From the previous formula, we know that, and here the area is the green, the blue areas here. So the curves, the area of this is the curves when theta from pi is equal to negative pi over 4 to pi over 4, right? At negative pi over 4, it will be exactly right here at the origin. And the angle theta increase to 0, it will be right here at this point. It continue going to pi over 4, and this is one loops, right? So the question is to find this area. According to the previous formula, we know that the area should satisfy this equation. A is equal to integral from A to B of 1/2 r squared d theta. In this case, A is negative pi over 4, B is pi over 4. So we have this integral, right? And R is given in this form. R is cosine of 2 theta. So at the end, we have this integration in terms of the angle theta. Okay. Now it becomes a simple integration. And the cosine function here is cosine squared. So we can use the half angle formula to reduce the order of the cosine function. Okay, and it becomes this. But before doing this, look at this. We can look at the graph here. It is symmetry with respect to this line, right? Which is the integral from negative pi over 4 to 0 and 0 to pi over 4, or it is double of the integration from 0 to pi over 4 of this function. Okay. Then we use the half angle formula. We have this term, and antiderivative of this function is this guy, and we evaluate the limit here. And finally, we find the area is pi over 8. That is the idea. Okay. The first example. Now, the technique is clear, right? Or do you have any question? Okay, if not, we move on to another example. Okay, find the area of the region. That lies inside the circle. R is equal to 3 sine theta. And outside the cardioid, R is equal to 1 plus sine theta. Okay. Excuse me. So the first things we need to do, what is it? Yes, graph it, right? We graph it. It means that we pick some special angle theta, and let us pick from 0 to 2 pi, and 0, pi over 2, pi, 3 pi over 2, and 2 pi. And there are two curves. So the first R is equal to sine 3 sine theta. The second curve is R is equal to 1 plus sine theta. Okay. Let us compute the first one. At 0, then R of the first curves will be? Yes. 3 sine 0 and sine 0 is 0. Very good. And at pi over 2, very good. Sine of pi over 2 is 3, therefore we have 3. Sine of pi over 2 is 1, therefore we have 3 here. How about at pi? Yes. And continue at 3 pi over 2. Yes. 3 pi over 2, sine of that will be negative 1. Negative 1 times 3 give us negative 3. So at 2 pi, very good. The second curves here. When theta is equal to 0, what is R? Yes. So, and here it will be 1 plus sine of pi over 2, which is 1 plus 1, and it is 2. Thank you. And here at pi, yes, 1. At 3 pi over 2, yes. And at 2 pi, very good. So, but actually, these points are not enough. It may not be good enough to draw a graph, but we've done these two. So we know that the graph of this guy would look like this. So the first one, suppose this is 1, right? It's 3. Then at 0, the first line is this guy. It is 0. It's not a good draw. That at pi over 4, there's more than 1, so it should be larger somewhere here. Yeah. It's not a good draw, right? But a graph of the left 3 sine theta. So, okay, let's just pick here. At 0 is 0, this point, right? Okay. 0 is this here, right? Okay, let us pick some more points. Okay. Pi over 4. Okay, let us do pi over 4. Then 3r will be yeah, and 3 square root of 2 over 2 is 2.1, right? It would be somewhere here, right? Oh yeah, 3 sine. 0 is here. At pi over 2, it will be 3, this point, right? And at pi, it will be 0. At pi, it would be 0, right? And here, 3 pi over 2, it will be -3. So let us pick a point here at 3 pi over 4. We'll see that, okay, it will be 3 times sine of 3 pi over 4, right? It is the same as 3 square root of 2 over 2, which is 3 pi over 4 is this angle. Then we have this point. At pi, it will go back to the origin here at 0. Okay. Then then at 3 pi over 2, it is 3 pi over 2 is this angle right here, right? It is -3. -3, it go back to this point here, right? But here, the angle, I know it's confusing. The angle is from here to here is 3 pi over 2, right? And the r will be -3. It means that at the 3 pi over 2, it go back to this point, right? Yeah, I know it's very confusing. But the best way is, so anyway, it will, if we continue doing this, it will draw a circle here. And the choroidoids here, the choroidoids, we have done that many times. We have shown that at pi over 2, it is 2, right? So it cut at pi over 6. Oh, it's not a good graph. It should be the lines should be somewhere here. Imagine it is a circle. Okay. This is how it looks like. I know it's not very good. okay? Or we can graph it like this, right? Or if, yeah, you pick some more points, you see it better. But for now, let us show it here in the graph of 1 plus sine of theta. So this is the graph here, right? When theta is equal to 0, it is at this point. And pi over 2 is right here. Continue going to pi. And from pi to 3 pi over 2, it will be this guy. From 3 pi over 2 to 2 pi. Create this one, okay? And another graph is the graph of the 3 sine theta. Okay, look at the graph here. It becomes this circles here. Okay, how it behave? So it will go like this, right? Here is when pi is equal to theta is pi over 2. Continue going to pi, go back to this guy, right? And we continue. At 3 pi over 2, it go back to this point. Okay? And continue to 2 pi. It cover the circles one more times. Okay? Okay. Basically, the idea is that. So these are the graphs of the two functions. And the question is, find the area of the region line inside the R, this curves, which is the red one, right? And outside of the choroidoids here, which is the blue one, R is 1 plus sine theta here, right? It means that we need to find this area. So is it clear? We know the target, right? Now let us compute it. But here, they cut at this point. Okay? So according to the formula, we know that the area we are looking for is the integral from A to B of 1/2. Let us compute the area enclosed by the red curves here, right? Let us call the angle theta is here is A, and the angle theta is here is B. 1/2 of R squared d theta. That is by the red curves, okay? And this area is the difference between the red curves areas here. Subtract what? The same limits, right, of theta and 1 over 2 times R squared. Let us call it R2 to avoid confusion. Okay, this is, we call it R1, where R1 is 3 sine and R2 is 1 plus sine theta here. So what do we need to do at this point? Thank you. So now our job is to find these position A and B here, right? It's very natural, right? Thank you, Luke. So how can we find this guy, A and B, the angle? Look at this. So here, at this point where the two curves cut, they have the same radius, right? Okay. It means that let us find the intersection of the two curves. So they intersect, it means that R, yes, R1 is equal to R2, right? Or the equation here, 3 sine theta is equal to the curves of the second lines here, right? Which is okay. Is it clear up to this point? That is the reason why we need to find it. Okay. So from this equation, can we find the angle theta and solve this? And how can we solve it? We subtract both sides with, because on the left and the right, they have sine theta here. So we subtract both sides with sine theta. Therefore, the left-hand side will be, yes, or let us do it quickly. 2 sine theta is equal to 1, right? Therefore, sine theta will be 1/2. Okay, what angle of theta give us sine theta is equal to 1/2 here? Thank you, very good. So here is the unit circle, sine axis is here, and sine of theta is 1/2, which means it would be this point. So, and remember this guy, theta will be the angle pi over 6, or theta should be pi minus pi over 6, or it is 5 pi over 6. So, okay, that is fine. It means that we found here theta is pi over 6 and 5 pi over 6. So we put everything into the formula. Therefore, the area will be A is equal to integral from pi over 6 to 5 pi over 6 of the first curve, right? The red curves here, which is 1/2 of r squared. And r squared in this case is 3 sine theta square t theta, right? And we subtract the area of the second guys, which is integral from pi over 6 to 5 pi over 6 of 1/2. And r of the second equation will be 1 plus sine theta. Okay. So it is very important to find the intersections here, and it is hard. So that is why we spend much time doing this. Okay, let us continue. Here, it becomes, what is it? One half we take out, right? And here 3 sine square, and it becomes 9 sine square, right? minus here. This is a perfect square, right? We can expand it. What is it? The 1/2, we can take it out of the integral, right? So it would be? Yes, or 1 square plus 2 sine theta plus sine square theta d theta. Okay. Okay, the first integrals here, it is sine square, so we should use, yes, the half angle formulas, right? And the constant here, we can take it out. It is 9/2 integral pi over 6 here, 5 pi over 6, and sine square, which is 1/2 of 2 theta, okay, half angle. And the second guy here is 1/2 pi over 6 here, 5 pi over 6. And okay, this guy is 1 plus 2 sine theta. And again, we use the half angle formula here, right? It will be? Yeah. So let us write it down. And it becomes an easy integral, right? So the final result of this guy, just do some more steps. It is pi. Double check it yourself at home, okay? And the second part is the arc length here. Try to go home and read this in advance and do this example. Try to do it. And next time we'll continue from here. Okay?